Okay, let's start with linear regression. Linear regression, this topic was recently added by the CFA Institute in level 1. Now, it might not be very important in level 1 because it is not connected to the other topics as much as the previous topics were. But in level 2, you will have linear and multiple regression. And that's why CFA Institute probably decided that let me introduce this in level 1 rather than giving a direct shock to students in level 2. So first of all, to begin with linear regression equation, I need to discuss few things because it is got connection with finance somehow. So generally I used to do this after I did equity, but since we are doing quants generally before, so I'll try to explain that through equity somehow connected, right? I'll do that. Now, what is linear regression? Now, in mathematics, a linear regression equation is simply an equation where you have y equals to a plus bx. Now, generally the equation is y equals to a plus bx. Now here, y and x are our focus point. Y is called dependent factor and x is called independent factor. I'll repeat, y is called dependent factor and x is called independent factor. Now let's assume y is a stock and x is a market, which means index, Dow Jones, S&P 500. That's a broader market. A stock is dependent on the market, by what rate, by what equation? That equation is linear regression equation. Here the word linear regression is actually there is only one variable sensitivity which affects the stock. That sensitivity is called a slope, or we call it as beta. This is our beta, also called as slope. Since there is only one beta as of now, we call linear regression equation simple linear. In level 2, you will see multiple betas and therefore you'll have multiple linear regression. As of now in level 1, we are studying simple linear regression equation where you have only one beta or one slope. Here, what are we trying to explain? We are trying to explain the variation of dependent variable. So we are trying to explain how much is the change in dependent. In my equation, dependent is y due to the variation in independent variable. And independent variable, there is only one. So that is x. So basically, we are trying to see the change in y due to the change in x. Remember, I told you y like a stock and x is like a market. Everyone with me? So there are two variables, dependent variable and independent variable. There are different names of it. Dependent variable is also called as explained variable, endogenous, or predicted variable. Just go through the name, don't memorize it. Independent is explanatory, exogenous, or predicting value. Do I have to worry about the names? No, I don't have to worry about the names because when it comes to the question, it is going to be very easy to calculate. For example, they've said, suppose you want to predict the stock returns. My stock is Y based on something that is here they've given GDP, that is X. Who's dependent on whom? Stock Y is dependent on X, which is GDP. Which variable is independent? They are asking which is independent. Who's independent here, guys? Stock or GDP? Who's independent here? Who's independent? Correct. The GDP is independent and the stock is dependent. So, very simple. Because the GDP is going to explain the things, it's used as a predictor of stock. Stock are being explained by GDP and hence stock are dependent while GDP is independent. So what did we learn till now? We learned simple linear regression equation. Simple linear means there is only one independent factor. Simple linear regression. By the way, regression is a line. So simple linear regression. When I use the word simple means there is only one independent variable. What is a simple linear regression? We are trying to find the value of y, which is dependent on x, but due to something. Those two things are a and b, which we write here as b0 plus b1 into x. Now I'll discuss with you all the components. Here we are trying to predict y based on x. Now guys, what is y? What is y? What is b0? What is b1? And what is x? Let me discuss with you all of those. Y is the dependent variable or dependent factor. Like I told you, stock. X is the independent factor or independent variable like market or index. B1 is called the slope, which you can use as beta. Beta is the slope. B0 is called intercept. Intercept, for your reference, you can use as risk-free. Risk-free rate is also called intercept. Remember, risk-free we discussed during the start of the time value of money. Risk-free rate is the rate of government bonds. So how much should be the stock's return? At least risk-free plus sensitivity, that is beta, into the market returns. So if the markets are increasing into the beta plus risk-free, my stock will also change. This equation is called simple linear regression equation. Here, how many independent variables I have? One. How many, therefore, how many slopes? This slope is denoted by a word called K. Slope is 1. In simple linear regression, there is only one slope. Understood? This is what our topic is. Now, if you ask me from the exam point of view, I will of course discuss the entire topic, but from the exam point of view, mostly they ask you two things: assumptions of linear regression that we are going to do, and the second, one of the statistics that they are going to ask you is coefficient of determination, which is called as R square. R square. What is that? I will discuss you. These two things are going to be prime concern for you in the exam. However, I'll discuss everything step by step, one by one. So this is the most important thing. Your simple linear regression, if you want, copy down this. What are each components? I will discuss with you. Y is dependent factor, B0 is intercept, or you can say risk-free. B1 is slope, you can use beta. X is the independent factor like market or stock or GDP, whatever you say. Please copy down this, and then I will do the further discussion. Okay. Clear? Okay. Everyone copied? Perfect. Perfect. Okay. Okay. Yes. So, see this. Where is our, yeah, here. Here they've given a diagram, a scatter plot of with ABC's excess return on the vertical axis. So ABC is a stock and S&P 500 is a market. So can I say stock is nothing but Y, which is dependent on market X. Now guys, here if you would notice, S&P 500 is a market, as I told you, and here you will see the different returns that are plotted. They have given the monthly excess return for both variables from June and on, right? And then you will see in that month, the excess return of S&P 500 was 7.8 and the excess return of ABC was 1.1. So somewhere they've given all the returns. For example, for May 24, they've given this. What do you see? The returns, they are so random, right? They are random. Correct? So this is how two relations that they are plotted. But do you think most of the times the returns are here, if you notice, Y is also negative, X is also negative. So most of the times the returns are in tandem. They both are going in the same direction. Similarly, here both are negative, except one, where one is negative, other is positive. Most of the times they are going in the same direction. Yes or no? Do you notice most of the time they are going in the same direction, which means X and Y are both negative or both positive most of the times, except this one point. Therefore, we call they are positively correlated. Just by looking at the diagram at scatter plot, we can say they are positively correlated. Clear? Now, this is just for your reference. What we did is in the equation is this. Check out this. Y is dependent on X. X is market. X is market times the sensitivity plus the B0. But here you will also notice in the equation there is something called E. E is called, this E is the most important thing. It is called error or the residual. Error or the residual term. I am going to discuss mostly about this error in a moment. Note my words. Our major discussion is going to be about what is this error. Give me some time to come to the discussion of this error. Now, this error is there in the formula, like error of the stock. Let's say this is stock I. So this is called error of stock I. What is this error? How do we discuss it? All those things I will do one by one. But before I go ahead, right? The linear regression equation, often called as the line of the best fit or regression line. That is the other name, which we just did. Here, the cap that you see on the top, like this, what you see on the top is called predicted value. What is it called? Predicted value. Predicted value. The cap that you see on the top is called predicted value or estimated value. That's why you see the word estimated or predicted. The cap. Okay. Here, the hat or the cap above or the parameter indicates a predicted value. Just remember, I'm just discussing all the terms. I'll connect all of that together, right? Now, what is my equation? My equation, again, I will write is y equals to B0 plus B1 into X. Now, what if in this equation, I just want to find one thing, keeping everything else on the other side? So if I want to find, let's say B0, how will I find B0? Take everything else on the other side. Y minus B1 into X. So you can just rearrange and find the answer, right? For example, here, they've given you the information, compute the slope and intercept from the regression using the example. So they've given you the information. They've given you covariance and variance. Now, covariance and variance, how do I find that? So guys, the formula for beta, for the first time it is coming, it is covariance of X and Y over variance of Y, variance of the stock, market, sorry, variance of the market, which is X. So let me write down, explain you. But before I go ahead, do you know what is the formula of correlation between two stocks? It is covariance of both the stocks divided by the standard deviation of both stocks, isn't it? Now, can I rearrange this as correlation between both stocks into the standard deviation? If I rearrange this, I will get covariance. Everyone with me? Everyone remembers this formula? Check. This is the covariance or correlation formula, which we already did in the past. Now, what is the formula of beta? Beta is always calculated between the stock and the market. Now, in our case here, the stock is Y and the market is X. Market is X. X is the independent. What is the formula? It is covariance over the variance. Covariance of both X and Y, but the variance of the market, which is X. But you already know, you can rearrange this. Instead of covariance, you can also replace it by correlation. So I can also write this as correlation xy into standard deviation x into standard deviation y over the variance of x. If I do this, I know on the top I have 1x and on the bottom I have square. If I cancel this, what will be my formula of beta? What will be my formula of beta? I will have correlation xy into standard deviation of y over 1 standard deviation of x still remains, right, in the bottom. Everyone, this is going to be my, not a second formula, it's the same formula, I've just rearranged. So if they give me covariance, I will use this. If they give me correlation, I will use this. Please note down these two formulas of beta. Covariance over variance of x, or correlation. If they give you correlation, it is correlation into standard deviation of y. Remember, y is my stock here. I'll write down y is my stock, which is the dependent factor. X is my market, which is the independent factor. Understood, everyone? Clear? Two formulas, everyone? Note it. These are new things, so just note it down. We'll discuss more detail and derivation of this when we go to equity, not now. Right now, just understand this. In derivatives, so in equities, when we go, that time we'll discuss its derivation. Now, check here. They've asked you what is the slope and the intercept term. Now, I have the covariance and variance. S&P 500 is market and ABC is a stock. So, in order to calculate the slope, which is the beta, what will I do? I will calculate the covariance that they've given to me, 0.000336 divided by the variance of the S&P 500, that is market, 0.000522. If you just do this, you will get a slope of 0.64, beta of 0.64. What do you mean by beta of 0.64? It means that it is the sensitivity of stock with respect to market. So if the market goes up by 1%, how much will be the change in the stock? That is beta. That is sensitivity. Understood? So how much will be the change in the stock due to the change in market? That is beta. Now in the equation, I know what is my equation? Y equals to B0 plus B1 into X. Now, I already have got this B1, that is beta. Correct. Now, how do I find the B0? So in order to find B0, rearrange everything. So it will be y minus b1 into x. Now, what is your return on y? They have said the mean return on the stock is minus 4.05. So you can use y as minus 0.45 and x is minus 2.7. This x you multiply with the beta, you will get the answer. So just rearrange and calculate everything, everyone. It's simple. If you rearrange this and calculate, you will get the B0. B0 is the intercept. In our equation, B0 is the missing term. If you have everything else, right, you can easily find the missing term. Clear? Just solve it. It's easy. Once you are done with this, I will discuss with you what is that we are trying to do. What exactly are we trying to do? What is the meaning of this B0 and what is the meaning of this B1? Once you get B0, you will realize your B0 is minus 2.3 and your B1 is 0.64. What is the meaning of this? The meaning of this is in the next slide. The slope coefficient of 0.64, which is B1, beta, what does it mean? It means that when the excess return of the market increases by 1%, stock's return is expected to increase by 0.64. Why both increase? Because the beta is positive. So if the market return will increase, stock return will also increase. If the market return increase, stock return will also increase. Intercept. What about the intercept term? The intercept was negative 2.3%, which means if I put the equation y equals to b0 plus b1 into x, assume your b1 is 0. Assume your b1 is 0. So this entire portion will become 0. So what is the minimum return on the stock even when b1 is 0? Even when market gives you nothing. So even if the market gives you nothing, even if the x gives you nothing, how much is the minimum return on the y? That is negative 2.3%. So it can be interpreted that when the excess return on the S&P is 0, if it is 0, then this entire portion will be 0, right? Then what is the return on ABC stock? That is minus 2.3%. So what is B0? B0 is the return on Y when X is 0. Is that clear, everyone? Correct? So now I've got my B0 and B1. Remember, B0 is the intercept, the minimum return. So guys, if you will notice here, what is my excess return? Again, they've given the same thing. Now, after explaining all this thing, let me discuss what are we trying to exactly do, because sometimes you will be wondering, what are we trying to do? And what is the assumption of linear regression equation? So let me now first ask all of you in the class, and I need everyone's support here. Let's take up an oil and gas company like Saudi Aramco. Everyone with me? Saudi Aramco, everyone knows? Arab American company, by the way. Aramco's full form is Arab American company. Of course, now that is entirely Saudi Aramco. Can you tell me what are the factors that will cause the prices of stock of Saudi Aramco to increase or decrease? Give me reasons. I have participants in the class. I need at least 5 reasons. Give me any reasons. Yes, I've got one reason. War. Okay, very good. I'll put war. Global crude prices. Okay, global prices of crude. Interest rates. Inflation, GDP. Right? What else? What else? What else? Political conflict. Yes, so I will say geopolitics. Also, guys, what about pandemic? Correct. Decrease in production. Yes. So can I say demand and supply, or the financials of the company? What if its profit is falling? What about the management? The management or the board, even that changes in the board and management, even that might affect the stock price, isn't it? What else? What else? What if there is a scam or a corporate governance, right? Correct. That might affect. What else? Regulations, correct? Regulations. Perfect. What else? What else? What are the factors that will specifically affect to the company only? Specifically affect the company only. Its business strategy. Its business strategy or business model. All of these factors, fraud, yes, or scam, correct? Now, all of these factors I've separated into 2 parts. Can I say the one on the left, which is war, global prices, this will affect all? These factors are called systematic risk. They affect all. But financials, management, scam, business strategy, they mostly affect the company itself. They are called unsystematic. Unsystematic risks are more company specific, and systematic risks are more market specific. What do I mean by that? Can I say the systematic factors that you see will affect not only Saudi Aramco, but all the other oil and gas companies also? War, interest rate, GDP, politics, they will affect the other oil and gas companies also, correct? Tax policies and all. But management change, scam, business strategy, that way is more specific to the company, isn't it? So company has 2 types of risk. Always companies have 2 types of risk. And now see the statistical part of it. Total risk of the company is made up of 2 components. systematic risk and unsystematic risk. Are you with me, everyone? Total risk is made up of systematic and unsystematic. Which one do you think you are more concerned? Systematic or unsystematic? Answer. Which one you are more concerned? Systematic or unsystematic? Now, most of the times people say unsystematic. Now, in reality, which one can you diversify? Can you diversify systematic risk? No. Can you diversify unsystematic risk? Yes. Assume you are an investor. Can you diversify this unsystematic risk? Yes, by adding more and more stocks. But you cannot diversify the systematic risk. That will always be there. This same thing has a name, statistical name. What is a statistical name? The statistical name for total risk is called sum of square total. What is it called? Sum of square total. Systematic risk is called sum of square regression. And unsystematic risk is called sum of square error. Error. Now, do you recollect what is error? Error is the unsystematic risk. By the way, there is a short form for this. This is called sum of square total, sum of square regression, and sum of square error. These are the statistical names for what I discussed. Understood? Everyone? Clear? Right? Until now, everyone understood? Right? Step by step. Gradually, I'll explain you the statistical way. So what is sum of square total? It is the actual and mean difference. It is the difference between actual and mean. Mean is the average, if you recollect, average. How do I use the actual? Let's say actual of Y, the stock Y. Actual of stock Y minus the mean of stock Y. Mean is denoted by this bar on the top. But it is sum of square. Remember, variance is calculated in square. So what do? We do the square of all this. Actual minus mean. I will write down. This is called actual minus mean. So what is sum of? Do you have to remember the formula? No, you don't have to. I'm just showing you what exactly it is. Right? Do not worry. You do not have to remember all this thing. Okay. What is this? This is composite of the regression, which is explained, systematic risk, and unexplained. The regression one is called the difference between the predicted value and the mean. Predicted value and the mean. What is the predicted value? Predicted value, remember I told you it's with a hat. Minus the mean of Y. Again, it is square because we are calculating the risk in square. So all this is square plus the difference between actual minus predicted. What is actual? Actual, you already know, it's Y minus the predicted of Y. Y is here the stock, nothing else but the stock. Again, square. Now, this is the statistical meaning of all those things I discussed. This I'm adding it in your notes, but now I will connect you with this, what they have given here. See this. Where is it? Here. In the ANOVA, after a couple of pages, okay? After this diagram, you will see under analysis of variance. Analysis of variance is short form called as ANOVA. What is total sum of squares? This is total risk. Remember, is a combination of systematic and unsystematic risk. So can I say SST is nothing but SSR, sum of square regression, plus sum of square error. For your reference, this is your total risk, this is your systematic risk, and this is your unsystematic risk. Guys, this unsystematic risk is called error. If you look at the diagram, the total difference between, remember, the actual minus mean, this is, guys, my actual and this is my mean. The actual minus mean was called as sum of square total, which is nothing but the difference between predicted minus mean. Where is my predicted? My predicted is here. Predicted minus the mean. This is what we call as sum of square regression. So this is called sum of square regression, which is what we call as systematic risk. Now they don't use the word systematic here, they use that in equity. And the difference between your actual and predicted, that is sum of squared error. This is your nothing but unsystematic risk. Remember, systematic risk is called regression, explained, and this is called unexplained or called as error. And SST is total. Keep this in mind. You don't have to stress about all of these. You don't have to memorize all of this. I'm just explaining you what is total, systematic, and unsystematic risk. Based on this, what I'm going to do is that I'm going to prepare a table, all that we will see later on. But that is what we are trying to do. We are trying to find the risk. Now, I told you in exam, they will for sure 100%, if they ask you one question from linear regression, they will ask you what is the assumption of linear regression equation. These 3 assumptions or 4 assumptions, I will just discuss you. Honestly, I will tell you, memorize it. Honestly, I'll tell you, memorize it. But what is the focus? The focus, what I was trying to explain, the regression equation, was this error. This error is called the residual error, or this is the unsystematic risk. Now, guys, if you make a diversified portfolio, which risk will disappear? Systematic or unsystematic? Unsystematic risk will disappear, but systematic will always remain. So the beta always remains. So in the long run, we assume the error will become 0. We assume the error will become 0. Therefore, practically, we only write this part. Theoretically, we write error in the formula, but when we go to solve, we only solve the one without error because we assume that the error will become 0. How? By diversification. Understood? Now, most of the properties or most of the assumptions that I'm going to do are based on error. Most of your assumptions are based on error, which is the residual term. So for sure, they are going to ask this, and there are 4 assumptions. You have to just focus on the 4 assumptions. These are the assumption of your simple linear regression. What is simple linear? Y equals to B0 plus B1 X. And technically, I will also write error. Of course, it doesn't exist because error is 0, but most of your assumptions are about this error. For sure, asked in exam. What is the first assumption? The first assumption is that there is a linear relationship which exists between Y and X, that is dependent and independent. That is assumption number 1. Assumption number 2, 3, and 4, all of these assumptions are on error. All of these assumptions are on error. Only 4 assumptions. The next 3 are on error. What is assumption number 1? That the variance of the residual term is constant as the observations increase. So let's say there are hundreds of observations. So the variance is constant. That is called homoscedasticity. If it is not constant, we call it as heteroscedasticity. Homoscedasticity means constant. Guys, if you look at both the diagrams on the screen, you will notice that they are not constant over the period. Here you will notice these variances over the period are increasing. With time they are increasing. So if they are not constant, if they are not constant, they will violate the assumptions of linear regression. So they should be constant. Otherwise, they exhibit a pattern. Okay. So just remember that the variance should be constant. That is called homoscedasticity. Then the residual term is independently distributed, which means the residual for one observation is not correlated with other observation. Not. There should be no correlation between the errors of two. So let's say stock one error or stock one unsystematic risk and stock two unsystematic risk. There should be no correlation. For example, I told you what is the unsystematic risk. Let's say there is a fraud which has happened in one company, and then there is a fraud in another company. Those frauds should not be connected. There should not be a correlation. Otherwise, it's a systematic risk. Understood? And the last, the residual term is normally distributed. So if I take the residual on an average, the mean of the residual will be 0. Normal distribution, remember? Right in the center, mean is 0. Only these 4 assumptions. These 4 assumptions, they have explained here in detail. Assumption number 1, linear relationship. Assumption number 2, homoscedasticity, means the error term should be constant. Third, they should be independent. The error term should be independent. They should not be correlated. And fourth, that they should be normal. The distribution should be normal. 4 assumptions for your reference. That's it. These 4 assumptions will be tested in your exam. I will tell you how are they tested. Okay, so until now we've covered all this thing, and see what exactly questions will appear in exam. Very much similar to what we've discussed. See this. First, which of the following is least likely a necessary assumption of simple linear regression? Least likely. The residuals are normally distributed. Yes, that is correct. Assumption number 4. Second, tell me guys, you can also tell. There is a constant variance of error. The error should be constant. I told you it should not increase or decrease. The dependent variable is uncorrelated with the residual. No. C is the incorrect. The error term should be uncorrelated. There should be uncorrelation. So C is the incorrect. Right? 4 assumptions only. And for sure, they will test this in exam. What is the most appropriate interpretation of slope? Slope is beta of 10. Guys, beta of 10 means what? If the market increases by 1, stock will increase by 10, isn't it? So if the independent increases by 1, the dependent will increase by 10 times. Clear? Can you tell me ABC? Predicted value of the dependent variable when independent variable is 0 is 10. For every 1 unit change in independent, the model predicts that the dependent will change by 10 units. Yes, everyone? Correct. B is the right answer. Understood this? Everyone? Clear? Now, this is one thing that they will ask in exam. The other thing is ANOVA table. Now, what is this ANOVA table? I will explain you what is ANOVA table right here. And whatever I'm going to do on the screen, based on that, you'll be able to solve everything. And that itself is going to be asked in exam if they ask one extra question. Generally, they ask only one based on that. So let me discuss what is an ANOVA table. This is where everything of your topic I'll cover from this table. First of all, there are 2 types of risk. Explained and unexplained. That is regression and error, isn't it? Can I say this is nothing but my systematic risk and this is my unsystematic risk? Together is my total risk, What is the statistical name of it? Statistically, we call it as sum of square regression, sum of square error, and sum of square total. So if you add both, you'll get the total. Understand? What is degree of freedom? Degree of freedom in simple linear regression, how many beta do you have? In simple linear regression, you have only one beta, only one independent factor. So in simple linear regression, you will always have only one degree of freedom for systematic risk. That is beta. Remember, systematic risk means beta. Systematic risk means beta or slope. There is only one slope. So K is the denominator, the denomination. is always 1 in simple linear regression. In level 2, when you will go, you'll have multiple linear regression. So you'll have multiple beta. Therefore, you will have k more than 1. Here it is always 1. So what is the degree of freedom for error unexplained? The degree of freedom is n minus k minus 1. N minus k minus 1. And since k is 1, it is automatically n minus 2. Now, if you add both n minus 2 and if you add 1, what will you get total? If you add both of these things, what is the total that you will get? You will get n minus 1, isn't it? And we know what is the degree of freedom? N minus 1. So this is sum of square, total. From total variance, if I want to calculate the standard deviation, or if I want to do the average, how do I do average? Remember, you did x minus x bar the whole square. You divided it by the degree of freedom. So what is mean? Mean sum of square is nothing but sum of square divided by degree of freedom. So for regression, we will use SSR divided by the degree of freedom k, which is always 1. So in this case, mean square regression is same because k is 1. But what is mean square error? Mean square error is sum of square error divided by n minus 2. This error is a problem. This error is our problem. Unexplained error is our problem. So what is my mean square error? My mean square error is sum of square error divided by n minus 2. But still it is in variance. If I want to convert that into standard deviation, I will do the square root of it. When I do the square root of it, I get standard error of estimate. It might sound confusing. So here it is called standard error of estimate. This is nothing but the standard deviation of the error. Standard deviation of the residual. Residual means error. So what is standard deviation? Mean square error square root. What is mean square error? Sum of square divided by n minus 2 and its square root. When you do the square root, you get the standard deviation. One thing, what is standard error of estimate? That is one thing. Second thing that I told you that they will ask in exam is coefficient of determination, which is R square. R square is sum of square regression divided by sum of square total. I know it might be sounding very complicated, but let me write. R square is regression sum of square this divided by this, the total. So what is R square? Sum of square regression divided by sum of square total. Now, what does it tell you? It tells you, let's say the total risk of the stock is 100. Let's say the total risk of the stock is 100. And from the explained, the risk is 60. Means, can I say 60% of the risk of the stock, 60% of the risk of the stock is explained, means it's systematic. It is affecting everyone. So what is the individual stock risk? Only 40. So what does R square or coefficient of determination mean? It means how much percentage of the total variation in X, in Y, the stock, is explained by the independent variable. I'll repeat, how much percentage of total risk in the stock, which is Y, is explained by the market, which is X. Now, guys, do you want most of your risk to be systematic or unsystematic? Means, do you want most of your risk to be explained or unexplained? You want most of your risk to be explained, right? So your R square should be high. And unsystematic risk, which is sum of square error, should be low. So if your R square is high and if your standard error of estimate is low, then we call the model that I used here, y equals to b0 plus bx, is called fit and good. What is the sign of a fit model? A fit model is the one which has high R square and low standard error of estimate. Note down this. Fit model is the one which has high R square. So most of the things are explained and low unexplained. Clear? Now to test this in the model, you are going to use y equals to b0 plus b1 x. So of course, you don't have to do all this thing, but I'm just giving you an information. So to use this model, you need to test the statistics. So either you will test B0 or B1. These two variables you will test whether they are meaningful or not, means whether they are 0 or not equal to 0. So it's a two-tailed test and it's an F test. F test. Here there are two variances. One is explained, another is unexplained. So that explained variance is mean of explained variance is mean square regression divided by mean square error. That is your F test. I know it is a lot of information, but I've written it right now. I will utilize it in the next part. This one table covers everything, covers your rest of the topic, Okay, a lot of information I have mentioned. Now I will tell you how to solve that. Have you copied down this or taken a screenshot of this? In exam, if you ask me what are they going to test, they are going to test R square. 99% of the times, I can tell you they will tell you what is R square. Very easy. I will tell you how to calculate. Very easy. See, check here. Let's go to this example. Can you come to this example, guys? This is called ANOVA table. They've given an incomplete. We have to complete it. So can we complete here? Guys, regression. How much will be the degree of freedom here? For regression, it will always be 1. Always 1. Error, it is n minus 2. How much is my n? If you look at the question, how much is my n? Yeah, here they've given n is 36. So can I say this will be 34, n minus 2? And therefore, this will be 35, n minus 1. This 2 will be given. Sum of square and error will be given. So if you add both, you will get the total. And what is mean sum of square? This is this divided by this. So this will be the same 0.00756. But in this case, it will be 0.04064 divided by 34. That will be your mean square error. And if you press square root of it, you will get this. So your unexplained, whatever the answer you get is this divided by this. And if you do square root, you will get this standard error of estimate. What is your R square? Your R square is explained over the total. So your R square is 15.8, which is very low. What does it tell you? It tells you that out of the total risk of the stock, around 15.8% is explained. The rest is unexplained. Understood, everyone? Just filling up the data. Clear? Right? Here, if they ask you what is the F is mean square regression divided by the mean square error. So if you divide these two, you will get your F. Can you divide both and tell me what is your F statistic? Can you divide this by this? Mean square regression divided by this. Can you tell me how much is your F? If you divide this, your F will be 6.33. Am I correct? 6.33. Yes, 6.33. And if they ask you degree of freedom, so on the numerator you have explained, on the denominator you have unexplained, that is error. So how much degree of freedom for the numerator? It is always 1 because explained is always 1. And for the denominator you have already solved, that is 34. Understood? Right? Now, what I'm going to do is not important for your exam, but just explaining you, they've calculated F statistic using whether the beta is 0 or not equal to 0, like a correlation test, and they might do a two-tailed test, calculating the F statistic and using the degree of freedom. Here, you can get the critical value, but what are we testing? We are testing whether the B1 slope is equal to 0 or not equal to 0. Null is equal to 0, alternate is not equal to 0. Now, when we go to the F table using numerator and denominator, you can go to the table and check. You will get the critical value at 5% significance level is approximately 4.1. 4.1. So how does it work? Remember, in F distribution, 4.1 on the top, the downside will be close to 0 because it is inverse, right? So if it is 4.1, the downside will be 0 point something. And you know, F distribution is always greater than 1, so we don't always calculate the downside. Now, our test statistic is 6.33, which will be somewhere here. So automatically, I will say the null is rejected. The null is rejected means the beta is not 0. Once you get the beta is not 0, then you can comfortably use this beta. Your test is approved. Now you can comfortably use beta in predicting your Y. So now you've got the license to use beta, you can say that. To prove this, I use the F test. But they say you can also use the T test. Remember the T test? The T test is mean minus the hypothesized value divided by the standard error. Remember? Here I will say mean of beta, hypothesized value of beta, and the standard error of beta. I can do that. Same thing like t-test. You already know how to calculate the t-test. They will give you the values here. They've given you the values. If you check here, they've said that the sample is 0.64, right? You're testing whether it is different from 0. So we are testing whether the null, that the beta is 0 or not equal to 0. Using the t-test. So my test statistic will be my mean minus the target divided by the standard error. Standard error, they've given 0.26. So you will get the test statistics 2.46. This you will compare with the table. For 95%, you know the upside is 1.96, slightly greater. If you take degree of freedom here will be always and always here. The degree of freedom will be n-2 for the error. Degree of freedom for the error is n-2 because there are two variables here. So it is n-2. And if you go to the distribution table, they've already given you the value. The value is 2.03, which is slightly higher than 1.96. So this is 2.03 and your test statistic is 2.46. Again, reject the null. We want to reject the null so that we can comfortably use beta. Why am I doing this fast? Because whether you test using F or T doesn't make any difference. In exam, you know how to use the F statistic and the T. T statistics, you are already aware. If they ask you F, it is mean square regression over mean square error. Process is the same. I don't expect this to come in exam. Absolutely blunt I am. I don't expect this to come in exam. I'm just teaching because they have mentioned it. All of this, they have just introduced for you to understand in level 2. For your level 1, I can completely say you can skip this right now for level 1. If it is only linear regression in your topic of CFA, for level 1, you can skip this testing. For level 2, you can understand. Maybe in 2024 and 2025, when they add linear regression and other topics also, then you can do it. Till 2023, your exams, this is not important. Okay. However, I'm explaining you, if you have time, you should go through it. Now, based on that, they've given a question. I will do the question and we will complete that part, right? Okay, let's see this. So I'll tell you how to do that in the question. Then probably you'll try to be able to understand that. An analyst is interested in predicting annual sales of XYZ. So this is my Y, sales, right? Following table reports a regression of annual sales against the paper product industry sales. So industry sales is your X. Okay. Now guys, intercept is your B0, slope is your B1. The values they've given, B0 and B values, and standard error they've given. The correlation is this. Guys, correlation is R. If you square it, you get R square. So can you square this 0.9757? Tell me, how much is your R square? How much is your R square? If you do 0.9757, yes, square, 0.9757 square. Are you getting 0.952? 0.952, yes, correct. What does it mean? R square means the variability in Y due to X. The variability of industry sales explains about 95.2% of the company sales. So out of the company's total variability, 95.2 is explained from the industry. Industry is my X, company is my Y. The answer is D. They have asked what is the closest to the value reports of R square and the interpretation of R square. Understood? Don't worry, they'll rarely ask any calculation. They'll mostly make you do the interpretation. Clear? Right? Now, guys, can you make an equation? What will be the equation here? How will you make up an equation here? Let's see. They have said based on the regression results, company's market share of any increase in industry sale is expected to be closest to. How much will be the increase in company's market share? That will be based on beta, isn't it? Beta is the slope. Beta is the slope, which is our case B0, B1. How much is the beta here? The beta, guys, is 0.276. 0.276. So they are saying company's market share of any increase in the industry sales. How much is the industry sales? Industry sales. Have we got the industry sales information? Anyone? Industry sales? Yes. We don't have the industry sales, but 0.2796. What does 0.2796 means? Means that if our beta is 0.2796 or approximately 0.28, it means that if the industry sales increases by 1%, then market share of the stock will increase by 0.28%, right? Or I can say 28%. Am I correct? Right? Everyone understood? The sensitivity is 0.28. That many times. Understood, everyone? 0.28. So that many times the share of the stock will increase, or the market share of the sales of the company will increase, because the beta is 0.28. Understood? If the beta was 1, then every $1 increase in the industry will help $1 increase in the company, right? If it is 0.28, that means 28%, not 100. Clear? Now, same thing they have asked here. See, they have given a lot of information, but if you read, estimated increase in travel time for a motorcycle computer planning. Motorcycle is this, to move 8 kilometers further from the workplace in London. Now, if you read the story, a study was conducted by British Department for traveling between locations in London. Data was collected for motorcycle and passenger. And linear regression was conducted using both types, where Y is urban travel time in minutes and X is the distance. So Y is the time, X is the distance based on B1 plus B0 for passenger and motorcycle. For motorcycle, we are being told what is the equation? Y equals to 2.5 plus 1.93 into X, and distance is what they've given is 8. Now, guys, estimated increase in time travel for motorcycle to move 8 kilometers further from his workplace. 8 kilometers. Now, this is default, so don't include this. Only include this. because 2.5 will always be there. How much is the increase due to 8? 8. So multiply 8 with 1.93 and you will get around 15.44. Am I correct? Which is like 15 minutes. So just using the equation, you multiply that. Why not this? Because this will always be there. Just because of this, how much will be extra? Extra. This will happen when you don't run 8 kilometers. This will happen when B1 is 0. So we only have to calculate this part, which is 15.44 or approximately 15 minutes. Next, based on the regression result, which model is more reliable? Now, when they tell you to do the modeling, here you can basically do the test. Everyone, based on the regression result, which model is more reliable? How can I do that? How can I do that? See, first of all, do we have information? Do we have information? What is the testing you can do at 5% or anything? See, which model is more reliable? That reliability is R square. R square tells you how much of it is explained. Whose R square is more? Can I say passenger cars R square is more? So passenger explains more than motorcycle. Passengers explain is more. The remaining is unexplained. So passenger has a higher R square, remember higher R square and lower standard error is better. So passenger car is better because its R square is greater. So the answer is, they are basically telling you which model is better. Anyone which has higher R square, its model is better. Next, consider 5 statement in a simple linear regression. The appropriate degree of freedom for critical t value used to calculate confidence interval around both a parameter estimate and predictor is the same as the number of observation minus 2. Yes, the degree of freedom in t we did n minus 2. That is correct, justified. No doubt in that. We did degree of freedom here. If you can see here, we did n minus 2. Correct? So that is correct. Last one, very easy. What is the appropriate alternative hypothesis to test the statistical significance of intercept? See, intercept B0 is either 0 or B0 is not equal to 0. Which one is null and alternate? So they are asking, what is the alternate? What will be the alternate? Alternate. ABC, very easy. Alternate. Yes, the alternate will be not equal to 0. Here, alternate is B0. B0 they've named as A1. Okay. So B, instead of B0, they've named it as A1. So I will also write here A1. So A1 is my B0. A1 is equal to 0 or not equal to 0. Why the other two cannot be the answer? Because first of all, alternate, these are A2. So A2 is beta and A1 is greater. No, they said 0 or not equal to 0. So it's a two-tail. That's it. If you see here, there is no complicated calculation. In exam, they might ask you something very simple. Find the predictable value. How? See this. They have given you a regression equation. And here, this is your B0, this is your B1, and this is your S&P 500 is your X. If they tell you X is 10%, just replace 10 into it. Just put 10 into it. Just put 10 into it and you will get the return of ABC. Very easy. Just put the value and you will get the answer. This is your, you can say X bar. Remember X bar? Based on X bar, you calculated confidence interval. What was your confidence interval? X bar plus minus standard error into Z or T. Remember that? So this X bar of 4.1, this X bar of 4.1, you can use to find the interval also if they ask. For which standard error they've given 3.67 and 95% predictable value, you will go for T with degree of freedom n minus 2. So if I go with n minus 2 degree of freedom, 36 and 95%, I will get this value. Based on this, you will find the confidence interval. No problem. It's the exact same way that you did it sampling. All you have to do is that when you find the mean, standard error they will give you. You know how to find the degree of freedom, and based on alpha and degree of freedom, how to find the T or Z values and calculate the confidence interval. No issue with that. Understood, everyone? And now the last thing in this model is that they have said what is the different functional forms of simple linear regression. Now, see, in the simple linear regression, you are actually testing, assuming that both the variables are same. So you are assuming y, when I say y equals to b0 plus b1 into x, for example, y, let's say, is the returns on the stock is in percentage, and the returns on market is also in percentage. Both are in percentage, right? But what if one is in percentage, another is in time? For example, how much is the returns on the stock based on the time? So then one is in percentage, other is in number of days. What if they are asking you the dollar value of a stock based on returns? So one is in dollar, another in percentage. When this issue happens, then we might have to change the model by applying log. Is there a calculation? No. They've explained you what are the different models where you apply log. So what you do in your model, you start applying log. Wherever you see your, instead of y, you start applying the log whenever you see the log. Now, what is log? Log means a relative change. And lin or linear means an absolute change. So there are three types of model for your y0 equals to b0 plus b1 x, not y0. Simply you can say y for your y. Now guys, y is dependent and your x is independent, right? Now when they say there are three models, log lin models means the dependent, which is y, is log and the independent is linear. When they say lin log, means the dependent, which is the first, is linear and the independent is log. And when they say log model, you have to use log for both. Now, what do you mean about log? Log means a relative change in the dependent is equal to absolute change in independent. That's why it's called log-lin model. Log stands for relative. But what is the opposite? Lin log? Lin log means an absolute change in dependent is equal to relative change in independent. And when I say log, both are relative. Now I know I'm just reading it. I'm just giving you the technique to understand. But if you see here, log lin means relative, lin means linear. So, or absolute. So log lin means dependent is log, which is relative, while the independent is linear. Lin log means dependent is linear, independent is log, and log means both are variable. Now you must be wondering, what are you doing, sir? Now, if they say log lin model, the y will be log. If they say lin log model, the x will be log. And if they say log, then both will be log. Do I have to do any calculation? No. You just have to know this. Based on this, there are questions which we will do and complete. Okay. Last 5 questions and you'll be done with linear regression. But before I complete, let me tell you, from this topic, your focus, if you want to go for exam, should be only to what is the assumption of linear regression equation and what is R square. R square. However, I'm doing everything here, including those which have got no relation with the previous and are slightly complicated. So let me complete that. The variation of dependent variable explained by the independent variable. Dependent variable explained by the independent variable is measured by the variation in the dependent explained. Remember, that is nothing but your R square, which is the regression sum of square. Isn't it? Regression sum of square explained. Not exactly our RSS. Remember RSS? or SSR, sum of square regression. It means the explained. Basically, they are asking you how much is the explained of due to market. How much of the risk is explained? The rest is residual. Residual is sum of square error. So that is not B. Residual is sum of square error. And the average of it is mean square error. So even not A. A and B are, by the way, the same thing. That's why C. I know it might be a bit difficult initially, but you'll get through it. Now see, in second one, they have asked, are the intercept term and the slope coefficient statistically significant? Statistically significant means you're doing the test. You will do the test. Here, since they have not given a lot of information, you can use any test. So which test will I do? You can take any test here. By the way, you know what is the degree of freedom here. For regression, it is always 1. For error, it is n-2. n-2. For error, it is always n-2. Now, what are we testing? How do I do the test? Based on the information. There is B0 and B1. Both you have to test. Guys, coefficient estimate and standard error. When you do this, you get the coefficient estimate and divide by standard error. Can you find this divide by this value? Coefficient divide by this. What is the answer? Coefficient estimate divide by this. Why? Because what is the t-test? Guys, the t-test, if you remember, is your value. Let's say B1 minus the target, which is 0, divided by the standard error. So I'm just taking the coefficient, which is B0 or B1 divided by the standard error, because anything minus 0 is the same, right? So if you calculate this, you will get your test statistic. Your test statistic here, if you divide both, it is going to be, yes, 1.05, approximately correct. And if you divide the second one, you will get approximately 17.9. Isn't it? Correct? If you divide this one and this one, you'll get 17.9. Correct? Yes. Now, even without the table, assume you don't have the table. You already know at any significance, at 10%, 5% and 1%. Even if you take 1% significance, what is your score? 2.58. Right? 2.58. Even if you take 5%, 1% or anything, 10%. They have said here 5%. So 5%, you know the value at 5% is 1.96 or slightly more. If you go to the T, it will be slightly more. Let's say Z, 1.96. What is my test for B0? B0 is 1.05, so it is below. So I will say fail to reject. B0, is it significant? No, because I failed to reject. So B0 is no. But B1 is 17.9, which is too high, isn't it? So I reject the null. Means it is statistically significant. Because what is my null and alternate? My null is that the value is 0. The alternate is not equal to 0. So if you reject the null, means it is not 0. Means there is some value. It is significantly different. It is a complicated one. I did it based on the available information. We tested B0, which is below the critical value, and B1, which is above the critical value. So we fail to reject B0 and we reject B1. Understood? Fail to reject means no significance. Slope is significant. It's not easy, but just I'm doing it for your reference. Don't worry. In exam, it might not be asked, but it's in the syllabus. So if you have time, do it. Okay, it will help you in level 2. Third one. Partial ANOVA table is given. Calculate T statistic and appropriate conclusion for B1. Now, see, this is a one-tail test. They are testing whether B1 is greater than 1. So guys, which side will be my tail? Tail is decided by the alternate. So my tail will be on the right side, isn't it? Isn't it? Correct. Now, how do I calculate my value? To calculate the value, here you will use again the formula. What is the formula? T statistic is you are doing the explained B1, right? B1 is explained. Take this value, mean 0.0228 minus the target is now 1 divided by the standard error. Divided by the error. Let me know what is the value you get. 0.0024. What is the value that you're getting when you solve this? 0.0228 minus 1 divided by 0.0024. What is the value that you're getting, guys? Minus 407. Minus 407. What did I do? Are we doing some mistake here? Yes, we are doing some mistake. What? Why are we getting minus 0.02? Why are we not getting the value? They said to calculate the test statistic. What's wrong? We did the T. What is the other test statistic that you can use, guys? If this is not matching, what is the other test statistic that you can use? The other test statistic that you can use. Guys, see, where is the problem? The problem is that we are using standard error, but if you see the standard error, which is 0. Your error is 0.0024. Am I correct? 0.0024. And the regression explained is 0.0028. What are we missing here? First of all, these are square. We need to convert this into what? We need to convert this into mean average. So how do I do the average, guys? How do I do the average? Based on the table information here. It's based on the table, okay? So here, based on the table, how much is my degree of freedom? You already know the degree of freedom for this is 1. And for this, it is n minus 1, which is the previous case. How much is the degree of freedom? Let me see the degree of freedom. Have they given here? Have they given me the degree of freedom? Results from the regression of the analysis are present. Have they given me the degree of freedom? No, they have not given me the degree of freedom. They should be giving me the degree of freedom. Have they given me the degree of freedom? No, I think there is some missing part. Guys, please write here. The n is 36. Please write here. Yes, I remember this question had a problem. N is 36. N is 36. Please write that. N is 36. So your degree of freedom for unexplained, this is not there in the question. It's a mistake. So N is 36, right? So the degree of freedom here will be 34. When you do this, when you divide this by it, then you get the mean square error. Your mean square error will be, this will be 0.0228, but 0.0024, when you divide that by 34, when you do 0.0024 divided by 34, what's your answer? Yeah. What's your answer? 0.0024 divided by 34. You will get answer of 0.007, 0.0007, right? Okay, 0.001 or 7? 0.0001 or 7? It's going to 1, right? Okay. Now, see, when there is too much of information, sometimes you get confused. They are testing beta. Now, beta value, actually, I have the beta value already with me. The beta value is this. And the standard error is this. I don't have to calculate. Here I did assuming 0. here I don't have to calculate all this thing. All this thing I might do for reference, but I don't require it. Now, in order to calculate test statistic for the beta, I will take 1.1163 divided by the standard error 0.0624. Now, instead of 0, I will take 1. So all this extra stuff that we did was honestly not required. Degree of freedom was missing. Ignore it. Here you will do 1 because now the target is 1. Based on that, what is your test statistic? Can you find that? Sorry. Based on that, what is your test statistic? Based on that, yes. Right? Everyone, can you find this? 1.1163 minus 1 divided by 0.0624. Now you will get your value as 1.86. That will be your test statistic, 1.86. And what is our, if this is 1.86 at degree of freedom 34, and with 5% significance, no, 1% significance. Now, generally for Z, 1% is approximately 2.58, 1%, right? So for T, it should be definitely more than 2.58. Yes or no? For 1%. Is it a one? Oh, my mistake. Sorry, it's a one tail. One tail. Sorry, it's a one tail. So guys, let's look at T one tail with 34 degree. T one tail with 34 degree. T one tail is 1% with 34 degree. We don't have 34. So we will check here. It is somewhere between greater than 2.4. We don't have 34 in the value. In exam, they will provide you. So it is greater than 2.4. I will just write it here as 2.4 for my reference, or greater than that. But I got the value as 1.86, which is lower. So I will reject or fail to reject. I will do fail to reject. So my answer is B, fail to reject. Understood? Fail to reject. Next, the appropriate regression model for a linear relationship between relative change, relative means log, in an independent. So guys, my independent X is Y equals to B0 plus B1 X. My X is relative. So this is log, and absolute change in dependent. Dependent is Y, which is absolute, that is lin. Which model will I use? I've already given you the hint. Lin log, lin log, lin log, lin log. Which one? B. B is lin log. What is lin log? Lin log means linear change in Y to a relative, linear change in Y to log change in X, which is linear means absolute. Absolute change in Y to relative change in X. X is independent and Y is dependent. Okay, it sounds confusing. Always write down the equation and see what they've told. When they say relative, I use log for X. When they say absolute for dependent, I use lin. Now see, lin log. That is called lin log model. I know there is no logic to it. There is no logic to it right now. But as of now, just remember this. I also sounded it, it sounded me very funny. I'll explain you the logic in depth when we go to level 2, not now. As of now, just use this technique to answer. Again, I'll repeat, in level 1, only one question, okay? Last, for a regression model, they've given us the model. The analysis provides that the standard error as 2.5 and the standard error of the slope is 0.8. A 90% confidence interval for the estimate of Y when the value of independent is 10. So first thing, guys, you will find what is the Y. What is the Y value? 5 plus 3.5 into 10. If you calculate this, 35 plus 5, you will get 40. Y will be 40. This is your X bar, by the way. This is your X bar. So what is confidence interval? 40 plus minus the standard error, whatever is the standard error, into the Z values. Now they have said 90% confidence interval. So what is the 90% value? You know it is 1.65, right? Into the standard error. Provides the standard error for the forecast. They've given standard error for the forecast is 2.5. So multiply with 2.5, you will get 40 plus minus. Can you do 1.65 into 2.5? Let me know what's your answer. 1.65 into 2.5. Are you getting 4.1? 4.125, or you can say 4.1 approximately. So now do 40 plus 4.1 minus 4.1. You will get approximately the answer as, yes, everyone? Correct, 35.9 and this. So the answer is C. Am I correct, everyone? That's it. That's the end of your linear regression. I have been repeatedly telling you that a lot of things are complicated here. However, I have drawn down everything, the linear regression model and the ANOVA table here. The ANOVA table here, everything in the ANOVA table. In exam, mostly they will ask you what is R square or the assumptions of linear regression. Understood, everyone? That is the end of your quants. I'm attaching the notes and this formula sheet for your reference. If you ask me in quants, excluding hypothesis and linear regression, the first 5 topics of time value of money, the data visualization organization, where you learned all the statistics, probability, common probability, and sampling. These are the most important topics. Most important. Now, I suggest you spend your entire energy on the 5 topics. The last 2 topics, I have explained everything, but you don't have to understand everything. My suggestion, personal suggestion, too much for the last 2 topics and too little will be asked in exam. So officially, I cannot say ignore them, but unofficially, I will say that the last 2 topics, your energy should be only 10%. The first 5 topics, your energy should be 90%, because in this case, in exam, if you want, you can write down somewhere and put my name. In exam, most of the questions will be from the first 5 topics. From the last 2 topics, total, there will be 2 or 3 questions, total. So let's say if you're going to put 100 hours in quants, example, okay, an example, I would suggest put 90 hours in the first 5 topics and 10 hours in the last 2 topics. In the last 2 topics, I've already told you what is important for our exam. In hypothesis, remember type 1, type 2 error, p-value, and test of mean. That's it. In linear regression, 2 things, assumptions and R square. These are your last moment study. If you feel that the last 2 topics are too much, I don't know what to do, in that case, only study this, go to the exam, come out happy and give me a call. If these things, if you are able to go through these things, great. I don't want you to spend so much of energy in the last 2 readings right now for your level 1. They are not worth it, to be very honest enough. I don't usually say it, but I have to say it because I don't want you to get stressed in quants. If you ignore the last 2 topics, which I call outliers, the first 5 topics are so amazing. Most of the questions will be asked from that. Is that okay? Clear? Right? However, since I'm recording it, so therefore I had to cover everything. Honestly, in many classes, I have upfront told students to cancel. Don't do this, don't do this, don't do this. Understand? Because see, you have to take a calculated risk between the risk reward ratio. If the risk reward ratio, if I do sampling, I get 3 questions. And if I do hypothesis and linear, which is too much, and together I'll get 3 questions, it is very much logically that you put more energy on sampling rather than the other 2 topics. One question that student asked me that, can I skip the last 2 topics? Well, I don't honestly say you should, but there is an alternate. What is the alternate? If you do the first 5 topics perfectly, then in the next 2 topics, if you don't recollect anything, it's fine. Personally, in my exams, I did not do hypothesis because I found it very scary. I did not even understand it. However, I ensured my other topics were so perfect that I did not lose a mark. Hence, I got 70 plus in quants also. But you also can do that if all the other topics are perfect. And then if you have time, then you can do whatever I told you. See, some risk you will have to take. And now, before I conclude the session, I'm going to tell you one very important thing. Very important. Please listen to it before you leave. We are not targeting anything below 70. We want to be above 70 in each topic. But the journey from 90 to 100 is very difficult. Now, this is what I'm telling you is very practical. Okay. From 90 to 100, the journey is difficult because then you need perfection. Then you need hypothesis and linear regression also to be perfect. I tell my students that we are targeting above 70, but not above 90. Because for above 90, you have to put so much of an effort. I would rather spend my time in revising the rest 90. Got it? So instead of going from 90 to 100, I would rather spend my time on revising the 90. So our target is scoring 90, not below 70, but don't try to go to 100 and perfect everything. If you have time, great. But since most of y'all are working and most of y'all don't have time, so I suggest our target is 90. So from 90 to 100, if you have to go, then you have to do topics in detail of like these, which will take so much of your energy. It's better I revise everything, isn't it? Clear? So remember, in CFA, we are targeting above 70, but till 90. Is that okay? Everyone? Any questions? Let me know. If not, I'll see you in the other topic. Perfect. Remember, we want 90, not 100. Okay, but we don't want anything less than 70. Clear? All the questions that I've done in the class, if you do this, enough for your exams. Enough for your exams. Thank you so much. If you have any queries or any doubts, you can always WhatsApp me. You can call me. Thank you so much. I'll meet you in the next session. Bye.